Greetings and peace from throughout the boundless universes. Thanks for joining us, this Shadow. Today, we are going to be showing some videos on some mathematical problems that are in the mathematical field, in the mathematical world right now, and how the solutions that mathematicians have come up with are insufficient, to say the very least, and we, with our new number line, have come up with solutions to these problems. And you can see how our new number line actually completes these paradigms and these paradoxes.
That's right.
So this is a show you won't want to miss, and you want to grab your pencils and your papers and cell phones, and you want to take down notes, because this is important for your children.
That's right.
You can show this to your children and for adults. Okay.
And tell them that this ain't never been seen before.
This is brand new information. This has never been seen before with the old number line, with the traditional number line, and now with our new number line series, you have access to this information, to never before seen information. So make sure you all pay attention. You can put you on my mouth.
Sit down with you while you talk to us.
Okay.
About supporting us and about everything else you want to talk about. But keep talking about math first.
Yes.
I don't want to rush. We got plenty of time. Take a deep breath. I know you camera shy, but I want you to relax and do your thing. Okay. Okay.
So, I wanted to say, before anything else, thank you so much for your support. There have been donations. We really appreciate it. And as soon as we can come up, with the number lines and the book, we'll show you what we're doing with the money. We're going to be totally transparent with everything that we do. So please do continue to support. Your money is going to go to very good use. We have a lot of things in store, like we said before. We have a lot of plans for the people and for the children. So we really appreciate all of those who show us love, thumbs up, and
like our videos,
subscribe
to our YouTube channel, New University. New University. Subscribe to our YouTube channel, please.
New University TV, actually.
And like our videos on Facebook. And as you watch this video, thumb up this video and show some love. We love to see hearts and stuff like that.
Yeah, we love it. We love seeing hearts. Yeah.
And what else?
And comment. Comment. Ask questions. We love to see questions, because we'll talk about it the next day. Even if we don't get to see the questions right then and there, because we're teaching, we're on the board, or we're reading, we'll read it afterwards and respond accordingly.
Yes.
So we like to keep the audience engaged. We like to have a communication with our viewers, and we like to answer any and all questions that you may have pertaining to mathematics or the readings of the Sacred Wisdom of the History.
Yes.
And we plan on continuing this reading this week, sometime this week. So watch out for that.
Maybe tomorrow, right? I mean, the next day.
Yeah.
Because I want to get back to it. That was good. You did good. We'll get back to it. Let me see. So the first video is called Basic Math, dividing a 0 by 15. That's the first video we want to show. I don't know. We should show it all the way through. It's a short video. And then we'll play it back, and then we'll stop it and pause it and let the people see.
Yeah.
And as BASTET already said, this is BASTET and BES, and we're IAML, Indigenous Aesthetic Mathematics and Linguistics. We're consultants, curriculum consultants. We're academic presenters. Thank you. Much love. And then We do all types of mathematics. But this shadow hour, we're gonna focus on something that we've been trending on. We've been trending on just 0 divided by 0 and any number divided by 0. We've been trending on that. Thank you. Thank you. Peace, family. So we've been trending on these zeros. And so this AM, this shadow hour, we're gonna focus on this video and a couple of others. But here we go. You want to start at that set?
Yeah.
Wait, hold on, sorry.
Okay.
Okay.
Do you want to know what $182 billion looks like? Warren Buffett, CEO and founder of Berkshire Hathaway.
Okay.
What I want to do is kind of show you two division problems that get a lot of attention for a lot of students not really understanding, or also getting them confused, which answer is which. So here I have 0 divided by 15 and 15 divided by 0. Now remember, division problems is the inverse operation of multiplication. So what we want to do when we're sometimes figuring out division is try to see if we can rewrite it as a multiplication problem. So here's what I'm going to look at. Remember, multiplication, if we're multiplying 15 times 2, what that really means is 15 plus 15, right? I'm adding, 2 sets of 15. Well, if I have 0 divided by 15, what that's saying is 15 times what is going to give me 0? Well, if I have 15 times 1 equals 15, then how many sets of 15 are going to make me 0? And the obvious answer is none. 15 times 0 is going to equal 0. There can be 0 sets of 15 will make a 0. So if I have no sets of 15, I automatically have 0. So therefore, this answer is always going to be 0. Anytime you take 0 and divide it by a number, you're always going to get 0. And the reason being is if you just work with your table, it doesn't matter. 0 sets of anything will always produce 0. Now let's look at it the other way. Here I have 0 goes into 15. So how many zeros go into 15? Well, again, if we go back from this property, if I say anything times 0 equals 0, well, 0 times 0 or 0 times anything is never ever going to equal 15, because 0 times any number is always going to equal 0, never 15. So therefore, that's why this answer is on D5. I'll explain everything one more time. 15, 0 divided by 15. That means how many times is 15 going to 0? Also, 15 times what number equals 0? Well, 15 times 2 means 15 plus 15. 15 times 1 means 15. So 0 would be 0 of the 15s, wherefore my answer would be 0. 3 times 0 would be 0 3's to add, so I just have a 0. So therefore, any number times 0 always equals 0. So now I look at the next step. 15 divided by 0. How many times does 0 go into 15? Or 0 times what number equals 15? Well, we just explained that 0 times anything always equals 0. So there's no number you can multiply by 0 that's going to get 15. And therefore, that's why it's undefined. There you go.
Okay. Okay. So now, what we are is. Okay. Please sit down. I'm gonna on the board. Okay, see. Please sit down. Okay. Now. Okay. So now, let me tell y'all what we're gonna do. Okay. We vibe everybody over to the video, and if you did, we're gonna go back over the video. So no worries. Don't even worry about it. Now look, I didn't realize that we had this on the board before I started the video. Well, I did because I wrote it, but I didn't realize I was gonna have to go up before I erase it. What I want to say is that you see the red, black, and green flag, and that flag is just fine. The red, black, and green flag is just fine. But for the record, I just want to say our flag, not that flag.
You don't want
Oh, yeah. That's one. I thought it was the other. You remember the, okay. You remember the wrong one we had?
Yeah.
I didn't want to show the emblem, you know.
Right. Okay.
But this one is great. This is the right flag. You full of surprises. I didn't even know that.
Yes, it is all flag.
Yeah, this is our flag. Black, red, and green. Now this symbolizes the people. This symbolizes the supreme people. The balance of the people. Okay? This red symbolizes the blood of the people. And this green represents the land of the people. Thus you get supreme people, their lifeblood and their land, homeland, their native land. And this represents our nationality. Because once you add our language to this, which is the language you're speaking, black, red, and green, hold this. I'm sorry, this is an acronym, right, for black, red, and green, to be our brag, B-R-A-G, B-R-A-G, our brag flag. So it's just an easy acronym to remember the order of the flag, because it's a lot of people have the flag in different color orders. So in order to remember natural order, it's black for the supreme people, red for the blood and the lifeblood, and green for the land, for the motherland. And this for the mother tongue. Our flag represents our mother tongue. So this is what we represent right here, the black, red, and green. That's our flag. So we just want to put that on record, right, man?
Yes, we were talking about this because we saw a flag that had the three colors, but in a different order. Yeah. I think that the other one was the one that we saw was like green, red, and black. It was like this. See how this is upside down? In that order. And this is not our flag. Our flag is black on top, red in the middle, and green in the bottom. This is the proper order of the colors. And this is our flag. Everything has to follow in order. And this is the order, the proper order of the flag. The same way after mathematics has an order.
That's right.
Supreme balance, ma'at. So does our flag, and everything follows order.
And so the black is always on top.
Yes, the black is always on top.
The black is always on top. Ma'at, supreme balance, the mother, the west, the woman, the water.
Right. Okay.
That's the blackness.
Yeah.
You see what I'm saying?
Mm-hmm.
Yeah, go ahead.
Don't let anybody change these colors up.
That's
Don't
right.
buy any t-shirts that have the colors mixed around. No sneakers, because they got a lot of stuff out there, a lot of imitations, a lot of flags, and a lot of things that you can buy. But unless it's in its proper order right here, this is your original flag.
That's
this
right.
is our original flag. And it's order right here. So keep that in mind.
That's right.
Mm-hmm.
So now, on the video, the guy wants to divide 0. I'm going to write it divided by 15. 0 alienate 15. Is that correct?
Yes.
That's right, large.
No, that's good.
Okay. 0 alienate 15. And then his second question, just to get to it, was 15 alienate 0. And so then we'll go equals and equals. So now, this is a good problem. This is a very good problem. Because we would like to point out in his explanation of what happened in the first case of 0, we'll use his 0 divided by 15. In his explanation of 0 divided by 15, you never got a real meaning for what it means to divide 0 divided by 15. What does it mean to divide 15 into 0, or to have 15 0 divided by 15? The explanation to that wasn't given to you. What happened was he used the inverse to try to prove the outverse by saying 0 times 15 equals 0. Now, although this statement is true, this statement is true, that does not make this statement equal 0. It doesn't mean that equals 0. We could think of plenty of cases where that doesn't necessarily have to equal 0 in other cases. So this don't mean that. So 0 divided by 15 equals 0 was never explained in that video. As he wrote it, we'll write 0 divided by 15 equals 0. That was never fully explained. Like we showed last shadow hour, when we said 0 divided by 0 equals new. 0 divided by 0 equals new. And we showed that. We showed that, let's say, any number 1 or -2 divided by 0 equals un. -3 divided by 0 equals un. -4 divided by 0 equals un. So we explained that you could show a child or anybody what the number equals just using the number line. So that's how you give an explanation or a visual proof of what you're about to show here. So now, when we move to this inverse, which is 0 times 15 equals 0, it's just saying if we took this division symbol, this alienation symbol, and we made it a times symbol or a multiplication symbol, and then that's 0 times 15. So this is called the inverse. So that's what he used to check that answer. This is called the inverse, or this is the inverse. So we'll take this down. So this is the inverse. 0 times 15 equals 0. It's the inverse. And although this is true, I just wanted to point that out because I'm a very good listener, and I know you are too. So what I want to point out is, is that in his next explanation, he said because anything times 0 equals 0. Now, when he makes that statement is not true. Let's write that statement out. N times 0 equals 0. That statement is not true. Although you could type in a calculator, and your calculator will say anything times 0, and your computer will say anything times 0 equals 0. We have shown, proved by way of new mathematics that that answer is really 0 n. 0 n. It's a new number. It too is on. Its inverse, we're going to show in 1 second. N times 0 equals on. So now, remember, we're going to show his video, and we're going to slow all this down, and we're going to show this again. So now, what we would like to do, we are going to do 15, alienate 0. So first of all, when you put that in your calculator or your computer, you will not get an answer. It will be error. It will be undefined. It will read indeterminate. So 15 or any number, alienate 0 or any number divided by 0 is undefined. But using new mathematics, that's why I said this number is important. Using new mathematics, we can define this number. We can define this number 0, 15. This number is 0, 15. Okay? So now, let's do like we did here and do the inverse. 15, like 0, 15 times 0. So let's write it right here. 15 times 0 equals what? It equals what? Let's write it a little bit further. 15 times 0 equals 0, 1, 5. 0, 15. Because n times 0 equals 0 n. So 15 times 0 is going to equal 0, 15. Now you have to keep in mind that the answer here is undefined. It's unknown in your calculator. So since this number is undefined, and now it is defined, then that means that this number has never been known, nor has this number ever been known. Because if you don't know the obverse, which is 15 alienate 0 equals 0, 15, if you don't know this obverse solution, then you can't know its inverse solution, which is 15 times 0 equals. You wouldn't know its true solution. You could assume that it's 0. You could assume that it's only 0, and you could work the mathematics. However, we're going to prove that this is the true answer as we already have. Okay? But this is the inverse of this number. Because remember that no one knows this number except now. So now, what we have here? Okay, yeah, so we got that. And so what we want to put here? That was just the proof of that. So now, yeah. And so this is the inverse. This is the obverse. Okay, obverse, obverse, inverse, inverse. Now there is one other operation that we normally show, and we can show it. We can show it. We can show that other operation. It's called the reverse inverse. And the way we do a reverse inverse is it's called the same thing as a check. If we were to write that number over here, we'll say 0, alienate 15 equals 0. Then we would say 0 times 15 equals 0. And this will be true because this is how you check those answers. Okay? So this is how you check those answers. I was going to save this to the next video, But I said, nah, we better go ahead on and do this now. So let's do the inverse, the reverse inverse of it, which is 0 times 15 equals 0. Okay, 0 times 15 equals 0. Let me do that 5 again. It's kind of sliding around right there for some strange reason, but yeah, 0 times 15 equals 0. So that's called the, bear with me, y'all, reverse. There I go again. All right, reverse inverse. So the reverse, inverse, and the inverse. So let's draw a line between here so we'll know the difference between those. And this is the obverse. So the obverse, the inverse, and the reverse inverse. And the reverse inverse actually checks our answer. Okay? So now, let's see. We want to do the reverse inverse of this. So let's put that right here. 15 divided by 0 equals 0, 15. Okay? So now, let's do the reverse inverse. That's 0, 15 times 0 is going to equal 15. Yep, we can see that. That 15 and 0 multiplied by 0 equals 15. So we get back 15. If we multiply 0, 15 times 0, we get back the same 15 we started with. That's how we check that. So we know this answer is a proof because we could put any number up here and divide it by 0 or alienate it by 0, and it equals 0 that number, 0 n. And whatever that number is, 0 n times 0 will give us back n. So these are new rules and new proofs in mathematics, but they truths in mathematics because they'll always work no matter what the number is. This is foolproof. Okay? So now, this is the thing that he didn't show you in the video. This is called a reverse inverse, but it's also called how we check. Check. But he wouldn't want to show you how to check because of the simple fact that that would include trying to make sense of this number, 0, 15. That would include trying to make sense of this number, the obverse, the inverse, 15 times 0 equals 0, 15 as well. And then we would go with the obverse, the reverse inverse, and look at the reverse inverse. It's 0, 15 times 0. 0, 15 times 0. And what that's going to equal? 15. 15. So 0, 15 times 0 will give us back 15. So this is indigenous aesthetic mathematics and linguistics. We have shown you here that 0 alienate 15 equals 0. We have shown you that its inverse is 0 times 15 equals 0. We have shown you that its reverse inverse is 0 times 15 equals 0. So we have shown you that in its inverse and reverse, the answer or solution is 0. And in its obverse, the answer is 0. Thus, we can conclude that the answer is truly 0 because the answer checks out. This is the check. 0 multiplied by 15 equals 0. This is our check. We started with 0. So we merely want to end up with 0. 0 alienate 15 equals 0. So we started with 0. So we want to end up with 0 when we come back the other way. And lo and behold, 0 multiplied by 15 equals 0. It checks out. So we have the reverse inverse to show and prove that this answer is absolutely correct. Now, we start here with 15. 15 alienate 0 equals 0, 15. Let's multiply that, or let's reverse inverse that. 0, 15 times 0 will equal 15. We will return 15. If we multiply this number by 0 or times 0, it returns us 15. Just like 0 times 15 returns 0. So we can return 15. So this answer absolutely checks out. So we can say that this answer is right by way of its inverse, or as we'll say, I apologize, reverse inverse. And so here we have the inverse, and it's 15 times 0 equals 0, 15. And this 0, 15 matches the 0, 15 here. Now, what I want you to pay attention to is this right here. In the video, he says any number. This is any number times 0 equals 0. That's not true. Any number, let's do it right here. Any number, that's the n, any number times 0 equals 0 n. Any number times 0 equals 0 n. Just like what we have. 15 times 0 equals 0, 15. N times 0 equals 0, 15, or 0 n. So this is where that number comes from. So n times 0 equals 0, 15. And the cool thing about this is this has an inverse. This has an inverse. What's the inverse of this? The inverse of this is division. Let's do it. N divided or alienate 0 equals 0 n. That's right. N alienate 0 equals 0 n. N alienate 0 equals 0 n. N alienate 0 equals 0 n. So since we did the obverse, this is the obverse, and we did the inverse, it's now time for us to do the reverse inverse. And the reverse inverse is going to be 0 n. Let's do it right here first. 0 n times 0 will give us n. 0 n times 0 equals n. And we got n, we started with n, we must end with n. And there we go. Lo and behold, we end with n. So we have no problem with this. So when we put this in the inverse, reverse inverse, we simply say 0 n times 0 equals n. And that's the reverse inverse. This is also called what, y'all? It's called a check. That's how we check the answer. So we know by way of the check, we show and prove that everything we have here is consistent around the board. We have new proofs, we have new mathematics, we have new numbers, we have a new, can't say that any number times 0 equals 0. No, any number times 0 equals 0n. And now we can say n alienate 0 equals 0n and not undefined. N alienate 0 equals 0n. We know the inverse. Okay? Of this number. So now, I think that's about it for that. That shows and proves what we wanted to show and prove about the video. So now let me show you what I'm talking about. Because I played the video, let me just move this, try to move this off the screen. Golly, never mind. Okay, let me see now. Okay, y'all ready, fam? Here we go. Oh wait, I'm gonna skip ad.
What I want to do is kind of show two different problems that get a lot of attention for a lot of students not really understanding, or also getting them confused, which answer is which. So here I have 0 divided by 15 and 15 divided by 0. Now remember, division problems is the inverse operation of multiplication. So what we want to do when we're sometimes figuring out division is try to see if we can rewrite it as a multiplication problem. So here's what I'm going to look at. Remember, multiplication, if we're multiplying 15 times 2, what that really means is 15.
Okay, right quick. When he said the inverse of division is multiplication, this is what he's talking about. 0 alienate 15, or 0 divided by 15 equals 0. And 0 times 15 equals 0. He was talking about the inverse. 15 divided by 0 equals 0 equals 0, 15. Or 15 times 0 equals 0, 15. So that's the inverse on this side. So we say the inverse of division, he's talking about this operation right here. Okay? That's what I want y'all to know, family. Just for those who didn't know. And if you think everybody know, don't think that. Just let us go slow.
Plus 15, right? I'm adding, 2 sets of 15. So if I have 0 divided by 15, what that's saying is 15 times 1 is going to give me 0. Well, if I have 15 times 1 equals 15, then how many sets of 15 are going to make me 0? And the honest answer is none. 15 times 0.
In mathematics, family, anytime somebody say these words right here, this when you watch the magic. When they say, if they say it's the obvious. If you hear anybody say it's obvious how this works, without showing them proof, but they say like, it's obvious that 15 times 1 equals 15. So then it's obvious that 15 times 0 gives you what? Nothing. That's not a mathematical proof. That's not a mathematical answer. That tells me absolutely nothing, because the word nothing is a concept. So from that, I learned nothing. But we was discussing 0 at that point, which is a number, and dividing a number by 0, or 0 being divided by a number. So at that point, we're talking about a number. And so we have to have a number as the solution. We can't have some concept as the solution. Infinity would even be a concept. that's not a solution. That's not an answer to the problem. Okay? So that's what we want to show. Now, let's get back to him.
Sets of 15 are going to make me 0.
Uh-oh.
And the honest answer is no. 15 times 0 is going to... Then how many sets of 15 are going to make me 0? And the honest answer is none. 15 times 0 is going to equal 0. There can be 0 sets of 15 will make a 0. So if I have no sets of 15, I automatically have 0. So therefore, this answer is always going to be 0. Anytime you take 0 and divide it by a number, you're always going to get 0. And the reason is you just kind of work on it.
Now, when he says set, if I have 15 sets of 0, then obviously my answer is 0. No, obviously the answer is 15 sets of 0. That's what you have. The answer is not obviously 0. The answer is 15 sets of 0. You see that? So if you have 15 sets of 0, then the answer is 15 zeros, not just 0. Okay? So now, because you can look up in mathematics, it's a form of mathematics called set theory. And you really should look into that. It's called set theory. And in this form of mathematics, it'll explain to you exactly what he's talking about. And one day we'll get into that because we get into infinities and infinities of infinities. So we'll get into Cantor and all of the other mathematicians that dealt with that. You know. So let's get back to him. I just wanted to point those things out to you.
A 0. So if I have no sets of 15, I automatically have 0. So therefore, this answer is always going to be 0. Anytime you take 0 and divide it by a number, you're always going to get 0. And the reason being is you just kind of work with your table. It doesn't matter. 0 sets of anything will always produce you 0. Now let's look at it the other way. How here I have 0 goes into 15. So how many?
Let me show you something. Which one of these is 0 sets of 15? Is this 0 sets? Let me get a new marker. Is this 0 sets of 15? Or is this 0 sets of 15? You see that? How do you explain that to a child? Which one of those is 0 sets of 15? At what point does this multiplication symbol become a set symbol? 0 sets of 15 or 15 sets of 0. You see that? So now, if you say it's 0 sets of 15, then you can't just say that this is simply 0. You can't just say that this is simply 0 and call that the proof. Because 0 sets of 15 would be 15 zeros. And 15 sets of 0 would be 0, 15. Again, we repeat. 0 sets of 15 would be 15 zeros. And 15 sets of 0 would be 0, 15. We're going to go a bit back and then we're going to go forward with it.
Take 0 and divide it by a number, you're always going to get 0. And the reason being is just kind of work with your table. It doesn't matter. 0 sets of anything will always produce you 0. Now let's look at it the other way. How here I have 0 goes into 15. So how many zeros go into 15? Well, again, if we go back from this property, if I say anything times 0 equals 0, well, 0 times 0 or 0 times anything is never ever going to equal 15 because 0 times any number is always going to equal 0, never 15. So therefore, that's why this answer is on P5. I'll explain everything one more time.
Okay, before you explain that, let's explain this. that in the video, he discusses or talks about zero, and I'm going to use his terminology. We use alienate. MIAT stands for minus, alienate, add, time. That's the order. Minus, which is subtraction, alienate, division, add, addition, times, multiplication. And one reason why we use it that way, because we say 0 minus 5, 1 times 2. You see that? We use those words to do it. And we even say 1 plus 1 and not really addition. But we use 1 add 1. So we'll get into that. So 0, alienate 15 equals 0 is what he showed you. 0 divided by 15 equals 0. And he showed the inverse. 0 times 15 equals 0. And here you can see the obverse, 15 alienate are divided by 0 equals 0, 15. And he shows the inverse by showing that inverse, 15 times 0 equals 0, 15. And he really didn't show these answers here because he didn't have answers there. He called them undefined. He called this undefined. And he said he was trying to say that by any number 0 times 15 equals 0, he was trying to make a correlation shift to, we linguists here, indigenous aesthetic mathematics and linguistics. 15 times 0 equals 0, 15. So he was trying to make a relationship between this answer and this answer and say by way of this answer, 0 times 15 equals 0. And this answer, 15 times 0 equals 0. Because in normal mathematics, 15 times 0 will equal 0, not 0, 15. So he was saying because anything times 0 or 0 times anything equals 0, then he was trying to make a correlation to 15 times 0 equals 0, 15. And that's not correct because that's absolutely incorrect to assume that. The assumption is wrong. 0 times 15 is 0. But you can't assume that 15 times 0 is going to be 0. No, 15 times 0 is 0, 15. In fact, this number is not even said 0, 15. We're just using that for clarity right now. This number is really said, and not to be confusing, I want to do it right here. If I got room. Right here. Yeah, I think I got room. Well, let's do it up here. This number is called UN. UN. This number here, N, alienate 0 equals 0. N, that 0 N is called UN. This is the original identity of this number. It's UN. So any number, that could have been 7 divided by 0 equals 0, 7. And we would say that number 7 UN. N UN. 7 UN. If it was 8 right here, then this would be 0, 8. And we would say this number 8 UN. 8 UN. 8 alienate 0 equals 8 UN. N alienate 0 equals N UN. Any number alienate 0 is going to be N UN. It's going to be UN. So the name of that number is UN. So that number actually have a numeral. It has a name. Okay? So now what I want to show you is that, again, is that he showed you the obverse. He didn't tell you it was called an obverse. He showed you the inverse. And then he did not show you the reverse inverse, which is the most important thing because it gives you the check proof. The proof of the solution that you check. 0 times 15 returns 0. 0 times 15 returns 0. So by way of this check, do we know that 0 times 15 equals 0? Not because 0 times anything equals 0. That ain't why we know it. The reason why we know 0 times 15 equals 0 is because the reverse inverse, which is the check, 0 times anything equals 0. That's why we know by way of the reverse inverse check. So when he made the assumption that this number would be 0 based on the conclusion up here, it was all wrong. And you can't do that in mathematics. So never assume anything. This is a totally separate operation than this operation. This operation has to be fulfilled, and it has been by way of new mathematics. Y'all clap on that. Now y'all thumb up that. You know what I'm talking about? That's the real deal right there. That's real mathematics. That's something that can actually help your child in school and help you in the university. Thank you. Oh, I'm sorry. I'm sorry, right there. I'm going back. Okay, there we go.
Go back to this property. If I say anything times 0 equals 0, well, 0 times 0 or 0 times anything is never ever going to equal 15, because 0 times any number is always going to equal 0, never 15. So therefore, that's why this answer is undefined. I'll play everything one more time. 0 divided by 15. That means how many times is 15 going to 0? Well, so 15 times what number equals 0? Well, 15 times 2 means 15 plus 15. 15 times 1 means 15. So 0 would mean 0 of those 15s, therefore my answer would be 0. 3 times 0 would be 0 3's to add, so I just have a 0. So therefore, any number times 0 always equals 0. So now I look at the next step. 15 divided by 0. How many times is 0 going to 15? Or 0 times what number equals 15? Well, we just explained that 0 times anything always equals 0. So there's no number you can multiply by 0 that's going to get 15. And therefore, that's why it's undefined. There you go.
Okay, it was simple as that. The last statement was, therefore, there is no number you can multiply by 0 and not get 0, basically, right? That's what he said. Kind of got thrown out there. Let me see. But that's what he said. Let me turn this off. So, we getting there, y'all. I have to be factual when I make the statement.
0 3's to add, so I just have to explain that 0 times any. The fucking idea that I'm looking at.
I need to be.
So look at the sign.
Sorry, no, sorry.
15, or 0 times what number equals 15? Well, we just explained that 0 times anything always equals 0. So there's no number you can multiply by 0 that's going to get 15. And therefore, that's why it's undefined. There you go.
There is no number that you can multiply times 0 and get 15. There is no number that you can multiply times 0 and get 15. There is no number that you can multiply times 0 and get 15. There is no number that you can multiply times 0 and get 15. This is 0, 15 times 0 equals 15. We just multiplied this number times 0 and got 15. And look at the inverse of that. 15, I mean not the inverse, but the traverse of that. 15 times 0 equals 0, 15. 15 times 0 equals 0, 15. So we have obtained this number. It's important that we have this number here. It's important that we have this number here. If we don't have this number, 15 times 0 equals 0, 15, then this won't work out. 0, 15 times 0 equals 15. We need that number to go backwards and forward with that answer to tell the truth this way and tell the truth that way. If the sentence is true this way, mathematics is a language, then the sentence should be true that way. And that is exactly what you have. Sentence true this way, sentence true that way. Sentence true this way, sentence true that way. Sentence true, sentence true. This is mathematical proof of what you just saw cannot be done in mathematics by no mathematicians on the planet Earth. It's not just him. It's no mathematicians on the planet Earth can do what we just discussed. So now, and that's only one video. So that's what I wanted to bring y'all this shadow hour, fam. Let me see what else what else we could do right quick. I want to do one more thing. If you see right here, I did explain this right here. So y'all take a good picture of this now. This is mathematics as you will know it in the future. This is the way it's supposed to be, fam. This is the way it's supposed to be. We're supposed to know the truth. We're supposed to be dealing in reality, not in lies. This can't be kept hidden. This has to be made known so our people know. Because it's ours. And it's only going to wake our DNA up. It's to our advantage that we know, that we all know. Now, we're going to have a series of doing things like that where we show a video and we walk through the video and we actually show the use of our new numbers, new number lines, and we're going to show new solutions to problems in operation, but we're going to show a video with high-level mathematicians doing videos, and we're going to show it. We ain't going to cut nothing, play it straight through, more than likely, then pause it, and pause it, and pause it, explain it, and show you what the deal is, what's missing out of mathematics. That's the kind of course that you on. New University. We should say New University, Invaluable TV. Please support and contribute by donation to our cause, to our purpose of bringing you this and showing all people this, showing our people this. Black power. Zero history, one history. So I want to show y'all a video on the history of zero base, on the history of one, and on the history of numbers. These videos on YouTube, you can watch them first if you want to. That's why I got it up here, because I want you to watch this. I want you to see this. And then if you watch it and then I show it and then I explain what's going on, you only going to benefit even more. It's only to your benefit. It's only to your knowledge. This is the revolution, y'all. This is the future. We'll be thinking, not playing games. So now, zero history. We want to watch a video on the history of the number one. And we want to watch a video on the history of numbers, period. And then we want to watch several videos. Notice we started 1, 2, 3, 4. Notice we already started at zero division, because that's quantum. But we watch video on division zero, but it's multiple videos we got to watch, quantum videos. Because these two numbers, 0 and 1, that makes up what you call your binary. I tried to use that pen again. That makes up your binary code. 0, 1. Binary. Now, what number does that look like? That's the number un. Your binary code is based on this number un, not really on 0 and 1. This number gave birth to your binary code. This is the real numbers behind your binary code. Un is the real binary. See, let me show you. Should I write that out or should I draw it right? Okay, we'll do it right here. This is the number new. I always do that. And that's sticky, but it's not stuck up there. So this is the number new. And if we wanted to count, we could go 4, 3, 2, 1, 0, no, -0, -1, -2, -3, -4. But in between here, on this line right here, is a number. And that number is 0, 1. That's that same number right there that became your binary code. 0 on, 0 new, 0 new, 0 1, 0 1. That became your binary code. And so, in a lot of computers, and I definitely need to show a video on that, on how computers count. See, that'll be interesting for you to see that too. That'll be interesting. How computers count. Google that. I mean, YouTube that. YouTube that. How computers count. And you'll see, you'll find that some computers use 2 zeros. But they don't use new. They just use 2 zeros. And they have an array. They have what's called a number array, where they may have 4, 3, 2, 1, -4, 3, 2, 1, and then 0, and then they'll have 1, 2, 3, 4, and then they'll have an array of numbers like this. Like you'll have all of these numbers attached to 1, like this, something like this. But then you may have more arrays between 3 and 4 than you do at 1 and 2, like that. And so these slowly become thinner as you move in closer. And then, indeed, I did this wrong because -1 is somewhere way over here. And then 1 is more farther back like this. And so the array tends to break down. It's spread out in big V's out here. You'll see, it looks like Kakea's needles. It looks like needles out here. Kakea needles. It looks like needles out there. But as it comes closer to 0, it starts to thin out and starts to break up into just like single lines. And so this tells you something, that the numbers get farther and farther apart. They closer together in some areas, and then they get farther and farther apart. So this tells you that a computer does not count like a human being. A computer can't register the word nothing. The word nothing, the concept of nothing being 0, a computer can't register the concept of nothing. Only humans can imagine such a thing. So, computers call that something. S-U-M-T-H-I-N-G. Computers call that something. So this is something. But that was the whole thing in 1999 when they wanted to change over the computer over to 2000, right? When they wanted to flip over to 200, right? When they wanted to just add that number, that seems like a simple number to add 1999 plus 0, 0, 0, 1, and then come up with 2000, and then put 0, 0, 0. But a computer does not count in 2. A computer counts in binary. So 2 would be 2 numbers. 2 would be 2 numbers. It would be 4 numbers, this number and this number. 2 would come out to be two different numbers, is what I'm saying. Two, because you have 1 and 1. So 2, the computer is actually looking at it like this right here. It's like a, what they call it? I don't need to mention, I don't need to look that up anyway. But that's what 2 would look like. So when it came time to shift gears and to turn this into a 2, it was a problem because in this 4-bit combination, there was no room to add another number. There was no room to add another number. So this is short a number. So then they had to change over and use binary in order to count 2000, in order to put this into a year 2000 perspective, to make it past the year 2000 scare, the Y2K scare. They had to change this to binary. And this is the results to that binary. But what we tell you is that this binary actually came from a higher system of number line called new and on. New and 0 new is on. And the same thing over here. And thus, the same on right here, 0 1. And the same on right here, 0 1. So then we will have on all these levels. And so we will have on here as well. We will have on. So this actually comes from this level of numbers. So let's erase that so everybody can see clearly. So we can say on, and we can say on, Now, we're not going to get off topic because we got into computer numbers, but if you look at 1, 2, 3, 4, and then you look at 5, 6, if you do the math and you look up particles and quarks, and you look up the number 6 in relationship to quarks, you might know what we're talking about and what we're dealing with on a physics level. So we would like to do a video on 0, the history of 0, and that's because we have the true identity of 0, which will tell you why they couldn't figure just the number 0, why they couldn't figure the number 0, why you only have this 0, and why you don't know about this 0, and why you don't know about on, the number on. And when you figure that out, then you'll know the true identity of 0, the number 0. And realize you put this right here. I'll write that again, nothing. Because that's the concept. So that's 0 right there. And so then this is on. So on is the true identity of 0, and on is the true identity of the binary code. That's what we want you to see. We want you to see that on is the true identity of 0, and on is the true identity of the binary code. So this number is the real number 0, on. It's the quantum 0. And so I would like for you to watch we're going to watch a video on the history of 0, the history of 1. Because, great segue, huh, my love?
Yeah.
Yes. Come.
I'm right here.
Okay.
You want me to clean this for you?
Yes.
Okay.
Please.
Just clean it up for you.
Okay. So, everything's up to blue. Yep. So, we want to show you a video on the history of 0 and the history of 1. And I ain't going to go no further because I wound up repeating. But Bastet, the beautiful goddess Bastet, is cleaning the board, y'all. So, this is our own personal You remember the lady from Wheel of Fortune?
Yeah.
Vanna White? Okay. So, sure. Yeah, really.
Vanna Black.
Vanna Black, that's right.
Vanna Black.
That's right. Facts. Okay. So now, right on that. No, that's good.
Let it dry.
Yeah. Thank you, my love.
You're welcome.
So, let me see. So now, I was gonna show y'all about the number one because we didn't go into this on the other video. We went into. We'll just say, well, for the sake of the video, we'll say 0, 8, and 8, 15 equals 0. We went into that paradigm. And we went into the paradigm of 15, alienate 0, equals undefined, but we said it equals 0, 1, 5, or 15 un. Remember, this number is said 15 un. That's the name of that number, un, 15 un. But to start with your children and to start yourself out, it's okay. You can say 0, 15, but just know that if you say 15 un, it takes you back to this number right here, up in this area, and it gives you information about this number. And that's why it's important that you don't just write 0, because this type of mathematics gives you more information. Let me show you what I mean by more information. You automatically know that the result right here tells you that this is some number divided by 0, 0, 15. This is some number being divided by 0. It gives you a link, so it takes you directly to the area in which the number originates and is in superposition to. You understand? When you do something to one end, it happens on the other end. So that, yeah. So you're right though. So from its origin, because nu and an are the origins of numbers. This is the origin of numbers. Okay? Realize in the mathematics that we have today, that they have today, this is as far as they go. This number one. This and so that's as far as they would go on our number line. But let's show where they go on theirs, on the traditional number line. Because this too is a part of our number line. Let's say on the traditional number line. But this is as far as they go. Okay, they don't go past 1, they go up to 1. Okay? Because 1 is a pole. Okay? So they go up to 1 and up to 1. But 1, 0, 1 is a mystery. 1, 0, 1 is a mystery. That's why all your classes are 1, 0, 1. So 1, 0, 1 is a mystery. It's room 101, the mystery room, 101. So now you have entered that room. You have just entered the room. You have just entered the dimension and the room of 101. Welcome to the Twilight Zone. Okay? So now, here we go. What we didn't cover in that last video, and he didn't cover, was there is also the number, let's do this. There is also the number 0, alienate 0. If you put that in your calculator, that too will be undefined. I need to make sure my phone is on the charger, y'all. Let me get that popping right now. Okay, got that going. Now, and we have showed this many times before. Many times before. But once again, my love, come here. Right quick, come in for a second. Yeah. Go to your calculator on this phone. That's your new phone. Just try to do it right now. Yeah. Okay. 0 divided by 0, alienate 0. Your answer is gonna read undefined. I thought you said you put a calculator on that phone.
It is.
Oh, okay.
Right here.
0 divided by 0, please.
0
Equals.
cannot divide by 0. So, what's the equal sign? The equal sign?
Yeah.
It says cannot divide by 0.
So it cannot divide by 0. My love, while you there, can you do 15 divided by 0? 15 alienate 0? 15 divided by 0?
Sure. 15 divided by 0?
Yep.
Cannot divide by 0.
Cannot divide by 0. So this number is undefined. This solution would be undefined or cannot divide by 0. And this solution would be undefined. So now, this is the amount of mathematics that you are missing so far. You're missing solutions to this and solutions to this. So that means the inverse, the reverse inverse, the inverse, the reverse inverse is all not known. Now, what you do know, or what they do teach is n, alienate n equals 1. So now, let's do this. Let's do this. So this number we see is 0. Set number 0. Let's not say that's undefined. We know this number now. This number is new. Let's not say this undefined. We know this number now. This number is un. And this number is 1. Now, family, I want y'all to be honest with me now. Look, 0, new, un, 1. In the center of these two operations, and this is the exact order that these operations are supposed to go in. My eye. 0, new, un, 0. In the center, it's the center numbers we just talked about. Un, new. Un, and new. And un, and un. And the center is these numbers un and new. 0 divided by 0 equals new. Again, 0, alienate 0 equals new. Negative 1, alienate 0 equals 0, 1. Negative 2, alienate 0 equals 0, 2. So now we can see these numbers on the number line. We can show our child how to divide those numbers on the number line. We can say, take the number line, the new mathematics number line, son or daughter, and I want you to place your finger on the number 4, negative 4. It's just like 15. I want you to place your finger on negative 4. And I want you to say the sentence. Negative 4. Alienate 0. 0. Equals 0, negative 4. Wow, that's why the negative would be important, because it would be 0, negative 4. So on this side, it would be negative un, but it would be 0, negative 4. Or this answer, let's say we had that answer, it'll be 0, 15, but we wouldn't want to put the negative right there. I thought about putting the negative at the end for all intents and purposes, but didn't want to confuse the people. So it'll be 15 negative on, or negative 15 on. Either way you want to say it. So that's what that will be. So these two numbers are real numbers. Now, we dealt with this one and we dealt with that one in the video. Now let's change this to n instead of 15. That was just for the video reminder purpose. Okay, there we go. Slow down. Okay, let's say now that we have 0 alienate 0 equals new. How do we inverse that? We simply say 0 times 0 equals new. 0 times 0 equals new. That's how we inverse that. So then let's write the inverse over here. 0 times 0 equals, hold on, I apologize. I apologize. That's my fault. That's my fault. What we're gonna do here, we gotta say that 0 alienate 0 equals new. But if we do the inverse, 0 times 0 is not gonna equal new. It's gonna equal 0 squared. 0 times 0 is gonna equal 0 squared. And that is the inverse. So now, again, remember up here that if we did the inverse, 0 times n equals 0. So that would be 0 times n will equal 0. So then we can write the inverse, 0 times n equals 0. And we can write that inverse. So we know the inverse here. And then we know the reverse inverse because we can simply erase this timetable right here. And then we can select this line. And we can say 0 times n equals 0. And the reverse checks out. 0 times n equals 0. So then we can write that. So then we notice that this is reflection. These two are the same. The same. The inverse and inverse are the same when you do this number. The inverse and the reverse, 0 times n equals 0, and 0 times n equals 0. The inverse, 0 times n equals 0, and the reverse inverse, 0 times n equals 0, are the same when we do this number. So this is the beginning of quantum entanglement, because we already have one that's the same, so we know we got to have some differentials. And here they come. 0 alienate 0 equals new. But 0 times 0 equals 0 squared. And what we, oh yeah, the reverse inverse would be new times 0 equals 0. New times 0 equals 0. That's the reverse inverse. So this here is something that you never seen. New and 0 squared. Okay? So now, if we move on down, we have n alienate 0 equals 0n, or n on. So what do we have to do? We have to do the inverse. N times 0 equals on. So let's do that. N times 0 equals 0. n. Kind of like this number, 0n, 0n. N times 0 equals 0n. So this number, its inverse equals its obverse. Its obverse is n alienate 0 equals 0n. And its inverse is n times 0 equals 0n. So the solution, the obverse solution, equals the inverse solution. Because this is the obverse. This is the obvious one we're working with. This is the obverse. Just like the seal on a dollar bill, you got the obverse and you got the inverse side of the seal. Some people say reverse, but it's not the reverse, it's the inverse. Okay, now, so now we have to do the reverse inverse is going to be on times 0 equals n. On times 0 going to equal n. And we checked that before. On times 0 carry the n. The n reaches over. The n is the answer. It checks out. So then we say on 0 n on times 0 equals n. Gives us back n. So that is the reverse inverse. And stand for it now, because this is also called the check. This is called a check. That's how we check the answer. That's our proof. That's how we check this answer as well. And so now, let's do this one. N, alienate n equals 1. Easy enough. N times n equals not 1 though. Wait, let's leave that there. Let's leave that there. N times n equals n squared. So this is important. This is important because n squared is the solution inverse to one solution, to solution 1. N squared is the inverse of 1. Now that's important because this means that any number times itself equals a square, but any number divided by itself or alienated itself equals 1. That puts 1 in a very powerful position because now any number square, its inverse is 1. Its inverse is always 1. So this tells you something about the number 1. The number 1 is not the number 1 square. The number 1 is just the number 1. But it does not include the number 1 square. The number 1 square is 1 times 1 equals 1 square. That's 1 square, 1 times 1. But the number 1 is n divided by n equals 1. But 1 times 1 equals 1 square is not that 1. Okay? So now, and there's some tiny little nuances and idiosyncrasies that we are showing this shadow hour that we have not shown in no other preview, in no other presentation. It's some idiosyncrasies and some nuances to the numbers that we have never shown. We have talked about these in this order, but what I'm showing you this shadow is certain underlying keys. When I show you that this inverse is the same as this reverse inverse. I didn't necessarily discuss that in other shows, in other sessions. When I show you that this zero square is not the same as this new, I think I have discussed that. But I think I brought new light to that subject, and you're looking at this now in the way it's presented this shadow hour. I haven't said it totally, but I'm vibing that you see it. And I'm not going to say it, but I'm vibing that you see what's happening. Okay? These two are the same, the inverse and the reverse. But this is not the same, the obverse. The obverse is zero. This is zero. This is zero. So all of these are the same. But this is the division. And these are by multiplication. But still, the answers are all zero. So this tells you something about the number zero. This tells you something about the number zero. About the number zero in the numerator position, though. Only about the number zero in the numerator position. That's what it tells you about. The number zero in the numerator position. It does not tell you anything about the number zero in the denominator position. You see that? So you can't assume anything about these numbers right here. These numbers are below this line. Somebody's going to bring that 2 down. Like that. Come right here. See that? It's above this line. Facts. 0 alienate 2 equals 0. Fact. 0 times n equals 0. Inverse. Fact. 0 times n equals 0. Reverse inverse to check. Facts. Proof. So that's that proof. But it has nothing to do with any of these other numbers. It can't tell these other numbers what to do. So then these numbers speak for themselves. They have their own language. They have their own tongue. So then this number, 0 alienate 0, equals new. We're in a whole new place where n can't go. Because remember, n equals any number. N equals any number, right? Except, I don't even like using this except that much. We'll use any number not 0 or new or un. Or any of our other numbers only to infinity. But n can equal any number, 0, not new, and not un. So n does not extend to 0, which tells you if n can equal 1, that's as far as they can go. I'm going to say that again. If n cannot equal 0, then n equals 1 is as far as they can go. They can't go between 1 and 0. They stop at 1. That's the pole. That's the singularity. Facts. Okay? So now, let's draw a line right here. So 0 alienate 0 equals new. Facts. 0 times 0 equals 0 squared. Inverse. Facts. New times 0 equals 0. Reverse inverse check. Facts. The proof. Facts. So here we have the number new 0 squared 0. And so here you see clearly that this 0 does not equal to 0 squared. It's equal but not the same. 0 squared is the result of 0 times itself equals 0 squared, which is inverse. A number times itself, n squared, its inverse is always 1. So a number times itself is always square, and its inverse is always 1. Facts. This is all checking out, family. Everything is looking very good. We have indigenous, aesthetic, mathematics, and linguistics. We have it all right here. It's all checking out, family. So then we can come down to the next one that was undefined, as this one was undefined, now defined. N alienate 0 equals 0n, or n on, because this number is really what? U n. It's really on. And it's pronounced n on. Whatever number this is, on. So now, if you want a definition of on, we could say that on equals any number in 0. It equals any number zeroed. 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 Past tense. Zeroed. It equals any number zero. So that does not mean the number don't exist. That does not mean it's zero. It means that it's been zeroed for a reason. Okay? So we can still count on that money. You still owe me. I'm not in the debt. The money ain't going nowhere. So now, n alienate 0 equals 0n. Let's do the inverse. N times 0 equals on. Inverse, facts. On, or 0n, n on, times 0 equals n. Reverse inverse check, facts. On times 0 equals n. Reverse inverse check, facts. We don't have no problem. We're rolling right through this thing. And the last one, I might as well write in what we got to put in there. Help me out here. Oh, yeah. Reverse inverse. Reverse inverse. That's the check. So now, the reverse inverse is 1 times n equals n. And we know the rule. 1 times n equals n. And n times 1 equals n. So now, unlike 0, when we do 0 times n, we get 0. 0 times n equals 0. But when we do 0 times 0, we don't get 0. When we multiply 0 times a number, we get 0. But when we multiply 0 times 0, we get square. Amazing, ain't it? That's amazing. Because now we know 0 divided by 0 equals nu does not seem so strange when we can take two numbers and multiply, two 0 called nothing numbers, and multiply and come up with a square. This square is something. 0 square, square, something. Nu, something. Has a weight, it has a measure, it has an amount, it has a form, it has a shape, it has a color, it has a size, it has a mass, it has a density. It's a real thing. So now, 0 alienate 0 equals nu, and 0 times 0 is 0 squared. And then nu times 0 equals 0. This is a little bit difficult to show. But remember, this number n times 0 equals 0n. See that? N times 0 equals 0 n. So wouldn't nu be an n? No, nu is not an n. N equals any number, not 0, nu, or un. So this rule does not apply to this number because this number, nu, is not a part of n. See, this is n. -5, -4, -3, -2, -1. That's n. 1, 2, 3, 4, 5. That's n. But n does not include 0, nu, or un. So that rule does not apply to this number. But that does make this number different, though. So we not write this 0 like this. So we say nu times 0. We retain some information. So that just means anytime we write 0 and a 0, then we'll always write it with this right here. Because if it's 0 alienate a number, then the answer is 0. But if it's 0 alienate 0, then we make a distinction between the 0. Because 0 alienate 0, then see these numbers combined? Equals, see that? So we showed it last night. We did the number line last shadow hour. We did the number line, we did it like this. And we said -4, -3, -2, -1, and then we drew 0 right on the number line. And so then you see this line going straight through 0. You see 0 on the number line? And that line going straight through 0. That's hilarious. Okay. -1. Now let's put 0 right on the number line. There we go. See that line going through 0? See that line going through 0? That's the same kind of line going through 0. Because we're at that point where we stand 1 times 0. See, we're at that high point, 1 times 0. We're at that point where they're not allowed. They can't go 1 times 0. So 1 times 0, we're at that point. We're at that 1 times 0. So we're at that point where we have to get some clarity. And I'm giving you that clarity. Anytime we write 0 as the numerator here, if we want to retain this information, then we write 0 this way. And 0 alienate 0 equals 2. And nu is right here. Nu times 0 equals this number 0. This type of 0. You see that? Okay then. And that's because n times 0 equals un. So nu times 0, we're going to retain the fact that our outverse was 0 alienate 0 equals nu. So then in order to retain this information back on this side, we put it in there. For the same reason n divided by n alienate 0 equals un, we retain that information about n by putting it next to 0n. And when we come back, 0n times 0 equals n. And we check out. So that relates, that takes us back to this number, 1 times n equals n, or n times 1 equals n. This is true when it comes to 1, because n extends to 1. So 1 is the identity at this point. Of anything multiplied by 1 equals that number. 4 times 1 equals 4. 53 times 1 equals 53. 1 times 4 equals 4. And 1 times 53 equals 53. So 1 is the reflective identity. So 1 takes identity at this point. Remember, 1 is really new, but 1 is assuming the identity of new because 1 can extend up to new. Or n can extend only to 1 and not to 0. So this only happens on this plane. Not on this plane. You would think you would intuitively think that if 1 times n equals n, and n times 1 equals n, and 1 times n equals n, or 4 times 1 equals 4, and 1 times 4 equals 4, or 1 times 53 equals 53, or 53 times 1 equals 53, you would instinctively think that if that worked like that, they were reflected. That surely, if you had 0 times 0, surely if you have nu times 0, like you have 1 times n equals n, surely what nu times 0 will equal just 0, but it doesn't. And surely, if you have 1 times n equals n, surely n times 0 will equal 0. And no, it doesn't. 0 times 0 does not equal 0, nor does any number times 0 ever equal 0. It will always equal some unknown. Because that number is multiplied times 0. 0 is in the denominator, remember, and not in the numerator. Whenever 0 is in the denominator, the answer is always on. If 0 is in the numerator, then the answer can be 0. 0 in the numerator, the answer is 0. 0 in the denominator, the answer is always on. This 0 in the denominator is different. I'm doing my best to show you that this 0 in the denominator equals this number nu. And this number nu times 0 equals this. Let's do it this way. Suppose we wrote this number like this. And it's the reason why we don't write this number like this. It's got something to do with n extended. Suppose we wrote that number like that. Now it may become a little bit clearer for you. 0 divided by 0 equals nu 1, 0, 1, 0 nu. See that? 0 divided by 0 equals 0 nu. Because n divided by 0 equals 0 n. So any number divided by 0 equals n on. So this is the number divided by 0 equals n on. But the reason why it's different is because this number is n, and this number is 0. And this number is this number divided by itself, and not a number divided by 0. So that's why this number is different than this number. And that's why this number is not that. That's why this number is simply nu. Because this is a number divided by itself, which matches this, a number divided by itself, which proves that this number here, nu, is the real identity of the number 1. And that is the things that your children and yourself can learn at New Mathematics. Those things right there have never been shown to anybody in the world. Nobody in the world can do this mathematics. Only here. And we're offering it to you. So please, have a free will offering or donation to IML or IAML. Or look up Pi Pittman, that's Pittman on Facebook, or Luanny Morales, LUANNY MORALES, Luanny Morales or Pi Pittman on Facebook. Hit us up, go to New University, or go to IML on Facebook and join that page. IML, IAML. All right, so that's basically it, y'all, for that one. I think we ran the gamut, and I think we did a very good job. And I thank y'all for listening and for staying tuned at such an early morning hour and for being understanding the importance of this. You got to understand it's a reason why I do this late. That's because during the day, I have to work. So we would like to get this done full time. We would like to be able to make this happen full time. During the day, I'm working on mathematics. I'm working on different formulas, different solutions. I'm writing a book. I'm building a curriculum. I'm writing a newspaper. I'm getting doing a fundraiser. But what's the thing called? The fiber guy. I'm getting graphic design done, animations, working on getting somebody to do that, working on the book, working on some illustrations in the book, some things like that. Want some pictures of some indigenous, some aesthetics, and some mathematics and linguistics to show that flavor in the book. Looking for somebody who can come up with pictures like that. So if you're that type of person with that type of creative ability and would like to assist IML, my aunt, the mother, with this great work, then please contact us at 929-392-9331. Or you can contact us at 347-876-2922. Once again, that's 347-876-2922. So you can contact us at either one of those numbers, and we'll be more than happy to assist you with anything you need. But mainly keep the questions about the mathematics to this page right here, because we want to answer the phone and have a mathematics question. Our phone line is really open to people that's really trying to assist us and, contribute, support, and donate. And if you're in a crisis, then yeah, for sure, call us. We're the right ones to call. We deal with all types of. We talked about last year, yesterday, that that BASTET and BES, they, along with Tahuti, Angeles, and Consul, and Canoe, they heal marriages, they heal relationships, and believe you me, that with this knowledge, it does give you the ability to reconcile relationships and paradigms, mainly other people's lives. A lot of times not in your own. I speak from experience. And with that said, family, I love y'all. I love Bastet. Bastet love y'all. Peace in the land. It's truly wonderful. Peace, family.